Let's talk about the changes that happened inside the Jiralib library. Hello everyone, this is Ali Reza. Welcome to the Mentor Code Lab. When I was recording the previous episode, I had to pause the video and deal with something in my office. And when I came back to continue the recording, between this time, I noticed that Turtivorti had done some changes into his repository and some fundamental concepts were added inside his repository. And when I looked at those infrastructure things, I liked many of the things he was doing. And I thought that, you know what, it's nice to have them inside my own system. And because of that, now I had to sit back and re-import those things that I liked the way I like it inside my own library structure. And I didn't even finish all of them because some of them need to happen inside JInventory and some of them need to happen inside gmachina. But long story short, I think that the way he is doing stuff is really interesting. Let me show you a piece of his code that makes things much easier. Now, I'm not going to open his repository inside IntelliJ IDEA because that would cause a new instance of a project. This is just my own local repository to look at. But if we go into his blocks, and what he was doing recently was a fluid tank, I think it didn't update the repository. But I hope that I can find something that is fairly new, and that is here. If you look at what he is doing for a block, notice that it's industrial block. We will look at that. But after creating a voxel shape for his custom model, this is how he's handling the initialization of the block. Let's take a look at what he's doing. He is creating a new instance of a block property. Now, this is his own class. And then he's just calling some methods in a chained command way on that instance, and he's defining some flags. For example, he says that, hey, this block has a custom block entity renderer. It means that the block itself will not produce any cuboid model. Then he says that, hey, it has a comparator output. Then he has the horizontal facing. Nice. And use rotated shapes for this voxel shape. Okay, because we have the horizontal facing, of course. Then he says that, hey, please produce some block entity properties related to this block. Now he says that this is the electrolyzer type for the block entity in it. And it should tick, interestingly enough. The right click needs to open a GUI, and it needs to drop the contents on the break, and it has a multi-block properties because he's dealing with multi-blocks. I'm not going to add this into my own library because I'm not sure how I should handle it right now. And I will talk about these multi-block structures at some point maybe. But long story short, I like the way he is doing this because if we didn't do it this way, then guess what? We have to have some class that extends our base custom class that has comparator outputs. Then if we have a horizontal facing or a general directed facing, that makes two different conditions and they will have branches for comparator outputs. And God, if I want to cover all the use cases that he's covering just here, I may have come face to face with at least, I don't know, 32 or 64 different abstract classes that will handle all the use cases. And that would become a headache for a user. However, the way he is doing it is really smart, actually. Now, how did he manage to do all of this? If I want to take a look at his solution, he has this industrial block. Let's find that. And shouldn't be happen here. It's inside abstraction. Now, industrial block is a block that is using state properties. And these, by the way, were block properties. So these are different things. But take a look. He has a Boolean for placing the opposite. Then a block entity type supplier should take block entity factory. That's an interface. Then the tick factory. That's another interface. As comparator as a Boolean. Then the three functions for comparator output. Then the block entity render type, a shaped factory. This is for his multi-block. A Boolean for right click to open GUI. A Boolean for drop content on break. Then can exists at some place. And then a map of direction and voxel shapes. And this is his constructor that accepts a block properties. Now, how is he doing this? Is that he's just using the properties that we sent in here and change things based on the properties. For example, should we use the opposite facing or not? basically, if it used a method, and I will show you the method in a few minutes, inside the properties, this would be a flag, and he is sending this flag here. Now, where is he using this flag, for example? Of course, in getPlaceState. So when he is putting the placing, remember I had two different classes, one for the horizontal facing and one for the facing block, and I had to cover this in two different places. But take a look. He says if it has a horizontal facing, then he gets the horizontal player facing, and he checks if it should be opposite, then he will change the facing to the opposite. He will set the horizontal facing. Then he says that the stat properties contains the property axis instead of the horizontal. Then he's just using the axis, and that's it. So he did combine my two different abstract classes, one for being the horizontal facing and one for being the facing, into a single use case, and he defines that block property in such a way that he can handle most of the things. For example, create block entity. He says if the block entity supplier is not null, then please create using the factory. Okay. Another example, if we have a ticker, if we should tick, then please create the ticker. Otherwise, call the super. Has comparator output. Well, we have a flag for that. But for the comparator output, if we have the flag, please use this comparator output. This is a tree function, apply state word pros. Otherwise, call the super, basically. Get renderer. And again, this was set by the properties up here at some point. Let me see. Render type. Properties.render type. So that block properties is the boilerplate of handling almost all the use cases in this complex block. Okay. And if I close most of the methods just to simplify things, and I don't use regions here, you see that the block properties, he did an internal class here. And again, inside block properties, he has another internal class, if I find it here, as block entity properties. And he has another internal class somewhere else called block entity properties. And again, these are handling things differently. He has some internal interfaces that says block entity factory, block entity ticker factory, and shape factory. Now, I dissected the whole thing in my own library. So I will walk you through many different things. Of course, I didn't change my block right now because we have to understand these changes first. And then in another video, I will come back and maybe I will get rid of this activatable facing horizontal and block with ITIC-BE. And we will see that if we can fix the whole thing inside the same structure that he has and how we can do things his way. Because honestly, this guy is only responsible of adding the ticker. This guy is responsible of adding the horizontal facing or the facing. And this guy is adding an activatable property. And you know, we can have another field inside our property for this, and we will take a look at adding our own stuff on top of that. In the future videos, we will come back and talk you through all these changes that happen. Basically, as you see, we have many things under the properties here now. We have ITIC logic in the records. We have ITIC operations, iField getter and setter under the interfaces, and our block entity stuff now has generics inside all of them. And we will talk about these changes. They are more than few, so I will not cover all of them here, but I did want to explain the reason behind these changes. The main reason is that using the same approach that he had on the block, at the very least for the block itself, is reducing many different use cases, and it's almost eliminating this situation, having many different abstract classes that are doing the same thing in different ways and covering different use cases. Also, he has somewhat the same approach for the block entity, means that if I want to show you under the block entity and abstraction, he has this industrial block entity. Now, industrial block entity is again the same concept. However, he is working on this library. It's not finished yet, or it may be finished. I don't know. He showed me an image that has an annotation on top that says it's a progressing API. However, I don't see it right now because maybe he didn't update his repository. He's a little bit lazy on this topic. Unfortunately, he updates his repository not as fast as many developers do. Anyway, the thing is that he is using these, the wrapper around the inventory, fluid, and energy all in one go here. And if we ignore this part, we will see that he uses something interesting, a block entity fields and a tick logic and a tick rate. And then on tick, he's checking if the tick is 0, means that it's the very first time that the block is ticking. Then he may want to initialize some things. Otherwise, he just calls on tick, and then he calls the internal on tick, and internal on tick is just checking every tick logic and executes the logic there. So if you want to use some approach like this, all you have to do is to produce these tick logics. And you see that on first tick, the tick logic is being retrieved from the properties again. It's not on the constructor, it's on the first tick. And then he calls the on first tick, and on first tick is a public void, so you can replace it if you want to. However, this means that we have to take a look at these properties. Now, properties is a method that is called internally. Now, create properties is again a protected abstract, but take a look. It returns block entity properties. Now, I told you he has a block entity properties, but this time he has block entity properties. His naming is a little bit confusing at sometimes, but if you look at the block entity properties, I think it's an internal class. Yes, it's right down here. Again, it's an internal class. I dissected it out. It has a reference to the block entity, a tick rate, and then a tick logic. Now, each property has this tick logic for itself, and he is providing inventories again here. But if you look, he creates some constructors for them. We will take a look at these, and he is covering inventories. We will not do that. And then he is adding a tick logic. He is calling the builder and builds the tick logic there. Long story short, if he is going to use this library, because he didn't use it yet, and this is why I say that it may change in future. If he is going to use it in future, the usage is just like the case that he used for the blocks. But instead of having the properties sent into the class, he will create those properties in the constructor of each block entity. As I said, he's not using it right now. All he is using is that updatable block entity for all of his block entities. I mean, if you look at this, there is a huge, not huge, but enough big list of block entities. They are 25 files. So he has 25 different block entities right now. And none of them, I checked them one after another, none of them is using this class yet, because I think it's a work in progress for him. And he's not confident enough to switch to something like this. But I did find the boilerplate of what he's doing robust enough to add it into my own library on Jiralib. And I did not add that inventory section on the block entity properties. So if I go with BE properties, you see that I'm not producing any inventories, anything there, because I think on top of the block entity properties, I will have few different extensions of this guy in future, and one for each, the fluid, the energy, and inventory, and then one for Machina that will have all the three of them inside of itself. And this will give you flexibility. For example, if you don't have any machines, if all you have in your mod are fluid tanks, you have a mod that produces fluid tanks. So all you will do is reference the G fluids and Jiralibs and maybe the dependencies for the reference and things like that on top. And then G fluids will have extension that is, I'm not sure, maybe called fluid B properties. And that would be it. It will provide an inventory for the fluid stack on top of this guy, and it will have this functionality, but the functionality added for the fluids, and that would be it. So you don't have to work with inventories, you don't have to work with energy. But if you want, for example, a battery that contains energy, now you don't have fluids, you don't have inventory, again you will have something like energy BE properties. If you want to have inventory without fluids or energy, you will have inventory BE properties. And if you have an advanced machine, you will have machine BE properties sitting inside G Machina. So this library structure will add upon what we have inside Jiralib right now, and it will dissect what Turtiworty had done, giving us more flexibility on top of the code provided by him. If you want to look into his repository, here is the repository to show you that I have some sort of permission from him. This is his response. I asked about some changes. This is me, by the way. I asked about some changes inside his code, and I said that 1.21 is changing things. I told him that I'm dissecting his repository and make libraries out of this. These two responses is somewhat giving me a permission for that. He says, I mean, if you're choosing to do that, then it's your responsibility to update it to 1.20, 1.5, because if you're making a library, then you need to maintain it, not me, not writing your library for you. Okay, I understand that. And he says, I also wouldn't recommend doing a lot of things I do. Hence, I haven't made them into a library myself. Well, I know what he's talking about, but I will talk about things in future. And he says, again, I mean respectfully, if you don't know what my code is doing, you shouldn't be using it. Well, I understand everything and that's it. So he gave me permission. I think he is not against the idea, because if he was against the idea by his licensing or anything else, he would mention it for sure. He would say that, hey, I'm against it. You don't have permission. This is my licensing or whatever. So I have permission to do what I'm doing. I'm not sure if he ever paid attention to his license or not, but his licensing, I think, I don't understand licensings that much, but I think the licensing means that I need to give credit to his code. So as much as I remember, I will add this piece of code on top of every code I produce, the author name and his repository. Although I have changed few different things here and there, but I will cover the base structure the way I think is suitable. Now, he says that he doesn't like what he's doing to be a library. I think he's modest. I really think he's modest, because the way I look at his code, if I had to write something, I wouldn't be as good as he did it. And I showed you I had some code before. By the way, some of them were the ideas that I got from watching his live streams, but I didn't mimic his code and I didn't copy paste his code. I did try to write my own. For example, the idea of having the abstract string handler. I had my own. But when I looked at his code, I was like, oh wait, he had done it much better. For example, the quick move. The concept is almost identical. And I talked about it. He uses a method and he did convert the logic a little bit here and there, and he added one extra line that fixes a problem I had. So when I look at his code, I say that, you know what, I had done something close to it, but he's doing it better. So why not use that? I'm not sure what he's referring to when he says that he doesn't like what he's doing. I think he's referring to his heat API and maybe gas and slurry API. I don't use them right now. By the way, this video is somewhat a brainstorming at the same time, and we are just talking and we are not coding. But I think it's a good video because, as I said, sometimes people don't know how to take the next step from being an educated starter programming for modding Minecraft toward getting something done. And these brainstorming videos can help on that. So when I look at his heat API, I get confused. I mean, I can understand it. He is thinking about a fluid as a medium to transfer heat. Okay, why a fluid? I mean, if we are talking about the heat itself, we can get things done without a fluid as a medium. Maybe something solid is transferring the heat. And if that's the case, we know that the point A is, for example, I don't know, 100 degrees, and I'm talking about centigrade, and the second point is 0. When we put these 2 points together and touching each other, the heat will be the balance of these two numbers, and it will be the average of these two numbers. So 0 plus 100 divided by 2 means that at the end of balancing each other, the heat will become 50 in both point A and point B. And again, if we touch point C to point B first, point C and point B will become 25 each. Then we have point B touching point A. Point A is 50, point B is 25. They will balance each other. So it will become 30 something, 36, 37, I think. I'm not sure at the top of my head. And then point B is 37, point C is 25. Again, they will be combined to each other and will be averaged. So this will continue until point A, B, and C all are the same value. If we think about that, I think we could have tweaked his library into something else that, not library, his code, into something else that doesn't need a fluid as the medium. And adding that fluid had made things more confusing and complex. So that's that. Also, when I look at his code, he is repeating himself. For example, he has this heat API, gas API, and slurry API, and he's just copy pasting from one of these APIs to make the gas API. I would say that if someone sits down and compares them, chances are that we can make something more generic that will handle those cases. I'm not sure about it because I didn't look at his 3 APIs for heat, gas, and slurry yet. But I think he's talking about that section of his code when he says that it's not good enough to be converted into a library. Because when I look at his code for the block properties, I like what I see. And when I look at his code for the block entity properties, so far I like what I see. And I don't understand why wouldn't this part become a library. Anyways, enough talking. In the next video, we will start talking about the changes that happen inside Jiralib. Now, keep in mind, they may have to jump from one place to another place because these things are working hand in hand. I will talk about the connections between them, but then I will finish one of them. Actually, they are coded. I will finish walking you through the code at one class, and then I will go back to another class. Remember, our block is not what we should have to be able to utilize that block properties. I did change his namings. The block entity properties, I changed it to block properties BE, and the block properties in our BE properties. I think these are better namings to identify them faster inside IntelliSense list. Okay, that being said, in the next video, we will start talking about something. I think it would be block properties because this is a good entry point to understand different things. Remember that we have some changes on our base structure, especially on block entities, to cover what we have inside BE properties. If you like these videos, please subscribe to the channel, hit the like button, and turn on that bell so that when I publish a new video, you will get informed. Have fun, everyone. Bye.